Hello everyone, we are going to talk about etch process with chemical material ratio. It's just a chemical reaction. We talk about it. And first of all, we talk about the wet etch as we talked about before. We use the HF solution, liquid chemical, to etch silicon oxide layer. Use this chemical reaction formula. And we use the S42 solution to etch the nitride silicon with this formula as we talked about before. This is the wet etch. Now the dry etch, etch with silicon oxide. The process gas to flow the plasma to etch as CF4, CHF3, C2F6, and so on. The CF4 ionizes by plasma energy to become two parts, F and CF. And silicon oxide with F, chemical reaction to become this and this to etch. Also at the meantime, silicon oxide meet CF2 separate to this. So the silicon oxide etched by the CF2 gas or F gas. Here we use the F and the CF2 gas. This is the basic dry etch process gas to etch silicon oxide. We want to increasing the etch rate. We can see this formula, CF4 with O to become COF2 and F. You can see that F increasing, F increasing, etch rate increasing. According to this, F increasing, etch rate increasing. So we use O for increasing F, then decreasing etch rate. But this reaction not no limit. If O too much, above 40%, the etch rate will be decreasing. So the O must control under 40% in the process. If we want to decrease etch rate. We use the etch. The etch add F to be HF. That means F decreasing, the etch rate decreasing at the same time, because we use the F to etch the silicon oxide. So the F decreasing, the etch rate decreasing. The etch controlled above 40%, the etch rate almost equal 0. So the etch is very effective. And a few etch, very few etch field, very few etch can improve selectivity of the silicon oxide and the silicon layer. So if you have two layers exposed to the dry edge, we add some edge, a few edge, to increasing the edge selectivity of silicon oxide and silicon. It's a skill, basic skill. We can see that the edge, dry edge plasma inner, the F for the edge, silicon oxide, and the C produce polymer. The polymer is a rubbish we don't want to have, but in some special case we have to produce some polymer to do some specific purpose, but most of the time we don't want the polymer because it will pollute the chamber and cause the yellow and make difficult for PM. We can use the CHF3 with blood gas to etch silicon oxide, just for better selectivity, and use the O and the SF6 and NF3 to increase the etch rate. Also at the same time avoid polymer, because O, SF6, NF3 including no C produce polymer. The NF3 gas we use to etch silicon nitride, just for the better selectivity. Why we use another kind of process gas? Why not use the CHF3 gas? CHF3 gas to etch silicon oxide, it for very good selectivity with silicon oxide and the silicon layer. But the CHF3 gas has very bad selectivity with silicon nitride. So we use it and F3 gas to etch the silicon nitride. This is the basic process gas. In a dry etch to etch with silicon oxide and silicon nitride process. Let's all see you next time.